I want to welcome you to the lecture for 13.4. This is MGF 1106, Liberal Arts Math, and my name is Jorge. So there are three objectives. We're going to understand the meaning of expected value. So 13.4 is going to be talking about expected value. We're going to calculate the expected value of lotteries and games of chance, and then we're going to use expected value to solve an applied problem. So the first example is it's about insurance and premiums. So the value of several items, along with the probabilities that these items will be stolen over the next year, is shown. And then we're going to go ahead and predict what the insurance company can expect to pay in claims on the policy. Now the premium for this policy is $100. So we're going to find out if this is a fair premium for this policy. And the first thing is that we have a list of the items, and then we have the value of each one, and then we have the probability of each one being stolen. So now what we're going to do with that is that we're going to multiply the value of the item times the probability of it being stolen. So, and then the last thing that we're going to do is we're going to go ahead and add up the last column, which is the expected payout. So again, we do 2,000 times 0.02, 400 times 0.03, 600 times 0.01, and so on. And then we have the different values, $40, $12, $6, and $32. And then what we do with that information is that we actually add them all up together. Now, just be aware that the first thing we're going to do is multiply the value times the probability for each of the items, and we're going to go ahead and sum that up, and that adds up to $90. Now, with an expected payout of $90, a $100 premium is reasonable for the insurance company. So here we have a formal definition of expected value. So let's assume that an experiment has outcomes numbered 1 to n, and each one of those outcomes has probability of P1, P2, P3, all the way to Pn. Now assume that each outcome also has a numerical value associated with it, and these are labeled V1, V2, V3 to Vn. So the expected value of this particular experiment is P1 times V1 plus P2 times V2 all the way to plus Pn times Vn. So now you have to be careful that you have to multiply the probability times the value first for each individual item and then add them together, and that gives you the expected value for that experiment. So here's an example. So how many heads can we expect when we flip 4 fair coins? So here are the probabilities. So number of heads 0, 1, 2, 3, or 4, right? Those are the possible outcomes when we flip 4 coins. So the probability for each one is given on this table. So the probability of getting 0 heads or all tails is 1 out of 16. Probability of getting 2 heads out of the 4 flips is 6 out of 16, and the probability of getting 4 heads out of the 4 flips is 1 out of 16. So here we know that there are 16 ways to flip 4 coins. Now we can go ahead and do a tree diagram to find out that we in fact have 16 possibilities. So how do we find the expected value? So then we take the probability of getting 0 heads times 0 plus the probability of getting 1 times the probability of getting 1 head times that actual probability, so that's 4 over 16, and then 2 times the probability, 3 times the probability, 4 times the probability, and then we add each one of those up. Now we end up with 32 over 16, which comes out to 2. So the expected value, if we flip 4 coins, is that we'll get 2 tails and 2 heads. Now, games of chance, right? So suppose you bet $1 on a single number of a 38 number roulette wheel. Now if you win, you get $35. You also get to keep the $1 that you bet, so you actually win $34. Otherwise, you lose the $1. Now what is the expected value of this bet? So here's the experiment. There are 2 outcomes. You win, so it's plus 35. You lose, which is minus $1, right? So then we know that there are 38 numbers. So the probability of winning is 1 out of 38. The probability of losing is 37 out of 38. So the expected value of this bet is the following. So you take the probability of winning, which is 1 over 38, times how much money you would win, which is 34, plus, and then here you have to multiply the probability of losing, which is 37 over 38, times what you will lose, which is $1. So then you multiply and then you add them, and then you find out that you can expect to lose about 5 cents for every dollar you bet. So this is not really a fair game, is it? So here's a definition. If a game has an expected value of 0, then the game is fair. A game in which the expected value is not 0 is called an unfair game. Lotteries, casinos, all those are unfair games, and usually what you do is you lose money. You lose X amount of money for every dollar that you bet. Here's another example. Assume that it costs $1 to play a lottery. The player chooses a three-digit number between 000 and 999 inclusive, and if the number is selected, then the player wins $500. Now, it's $499 considering that you have a $1 cost. So what is the expected value of this game? So state lottery cost is $1, the prize is $500. So the probability of winning is 1 out of 1,000. The probability of losing is 999 out of 1,000. So the expected value for this particular game is the probability of winning times the amount that you'll win, which is 499, plus probability of losing times the amount that you will lose. Then you find out that it's negative 0.5. So if you play this game, you can expect to lose 50 cents for every ticket that you buy. Here's another example. Assume that it costs $1 to play a lottery. The player chooses a three-digit number between 000 and 999 inclusive. Now, if the number is selected, then the player wins $500, $499 and a $1 cost. Now, what should the price of the ticket be in order to make this game fair? In other words, the expected value would be 0. So the first thing is we're going to let X be the price of a ticket for the lottery to be fair. Then if you win, your profit will be 500 minus X, because that's what you bet. And if you lose, your loss will be X. So the expected value of this game is the following. The probability of winning times the amount that you won, which is 500 minus X, plus the probability of losing times the amount that you will lose. Then you get an equation. 500 minus 1000X over 1000 equals 0. Because remember, the expected value has to be 0 in order for it to be a fair game. So now we have this equation. We're going to have to solve for X. And then when we do all the algebraic manipulation, we find out that we end up with 0.5. So for this game to be fair, a ticket has to cost 50 cents. So here's another example. A test consists of multiple choice questions with 5 answer choices. 1 point is earned for each correct answer. 1/3 point is subtracted for each incorrect answer. Now, questions that are left blank don't get points, don't lose points. So the first thing is find the expected value of randomly guessing an answer to a question. And then we're going to see what this means for a student. And then if you can eliminate one of the choices, is it wise to guess in this situation? So the first one, the probability of guessing correctly is 1 out of 5. The probability of guessing incorrectly is 4 out of 5. So the expected value, if you do the formula, is negative 1/15. So you actually lose points simply by guessing. Not a good thing to do if you're a student. So the second one, eliminating one answer choice then reduces the probability of guessing correctly to 1/4 and also reduces the probability of guessing incorrectly to 3/4. So the expected value in this case is 0. So if you can eliminate one of the choices and then you're down to 4 choices and you simply guess, you're neither going to benefit or you're going to be penalized in the long run if you do this. Here's another example. The manager of a coffee shop is deciding how many bagels to order for tomorrow. According to her records, for the past 10 days, the demand has been as follows. So you have 40 bagels, that's for 4 days, 30 bagels for 6 days. So she buys bagels for $1.45 each and she sells them for $1.85. Now, unsold bagels are discarded. Find her expected value for her profit or loss if she orders 40 bagels for tomorrow morning. So what we want to compute is the probability of demand, that it's 40, times the profit or loss if he orders 40, plus the probability of demand that it's going to be 30 bagels, times the profit or loss if the demand is in fact 30. So now the probability of demand is for 40 bagels is 4 out of 10, because if you remember from the table, it was 4 and 6, so it's 10 possible outcomes. So 4 out of 10, and the probability of demand for 30 bagels is 6 out of 10. So then, if the demand for 40 bagels, so we're going to do 40 times 185 minus 145, which is going to give us 40 times, 0.4. That's going to give us a $16 profit. Now, if the demand is 30 bagels, 30 times 0.4, we make a profit of $12. But we lose 10 bagels at $1.45, which is $14.50. So, 40 bagels, a profit of $16. 30 bagels, we lose $2.50, which is the difference between 12 and 14.50. So the expected profit or loss on 40 bagels is 0.4 times 16 plus 0.6 times negative 2.50, and that gives you a $4.90 profit. So if she orders 40 bagels or she doesn't order 40 bagels, the expected profit would be $4.90. And that's the end of section 13.4. Thank you.